that we're going to continue on with the quadratics, and what we began in our previous class. We're going to try and finish it today. And
Yeah.
we started off with completing the square, and just as how we're going to do the entire application of completing the square, along with what you may call, when you have to how to identify when the examiner is actually asking you to use completing the square. All right, that is far more important as well, because unless and until you know what the examiner is asking, then you cannot be then you can never actually go wrong. And at the same time, when written in completing the square form, like the final form, it also leads you to the x coordinate and the y coordinate of your turning point. But the only difference is that your x coordinate is the opposite of what it seems in the completed the square form. All right, Pasha?
All
Any
right.
issue with this so far? This is not that difficult at all. All right. Okay.
Okay.
Now, before I'll do the questions at the end, but before we do that, let's now move on to discriminants. Now, this is probably the more, you can say, important topic, because completing the square, obviously, a lot of you prior knowledge has already been given to you because it is also studied in IGCSE. So when I look at discriminant, just as I was doing completing the square, let's look at discriminant. Okay. Now, whenever we're talking about discriminants and quadratics, technically we're trying to understand the x-intercepts. Or now these x-intercepts are also referred to as, your real roots of the equation, the quadratic equation, or your solutions to the quadratic equation as well. All right. So the use of the discriminants in quadratics is to find the x-intercepts, which are also referred to as your real roots or your real solutions as well. All right. So if in a question it says that, find the real roots of a solution of an equation, or find the real solutions of an equation, technically what they're asking you is to find the x-intercepts. Now, those x-intercepts can be with the x-axis. Obviously, that's like the most common idea behind it, but they can also be the x coordinates of the intersection of uh, two graphs, two curves, a straight line or a curve, or anything of that sort as well. So it depends on how the question is asking. All right. So your position of your x-intercepts and your what you may call the number of your x-intercepts as well, how many are there, they're going to be determined by the discriminants, and it is also going to help us identify what sort of shape or position your graph is currently in. All right. So first of all, let's look at it from this point of view, that I'll draw x and y axes like this. Now, but it is common knowledge that if I draw a graph, surely, there can be different versions of the graph, like it can be like this as well. But there is one possibility that the graph cuts both the x and the y axis. Oh, there's a possibility that the graph cuts the x axis twice, like this. It's a possibility, right? We're not sure that this could happen, but at the same time, it's a high possibility that this can happen. Clear? At the same time, the graph could be like this. Now, considering these two graphs, Parsa, but we're not really concerned about what these graphs are. But there is one thing common about these graphs is that both of them intersect the x-axis at 2 points. So both of them have almost, not almost, but both of them exactly have two in x-intercepts each. Clear?
Yeah.
Keeping this in mind,
So
whenever.
basically, they have 2 points of intersection. They have two x-intercepts.
Mhm.
So they have two real roots, which means that the discriminant has to be greater than 0.
Yes, Parsa, perfect. So whenever you've said it excellently. So whenever there is your, 2 points of intersection. Now I'm not saying points of intersection with the what you may call with the x-axis, because at times the question might say that the curve was intersecting with a line. A question like this could come. So for that question, what you're going to do is that you're going to put these two equations, the one of the line and the curve, together, and then try to solve them using the discriminant. So whenever there are 2 points of intersection, that means that two real roots, and you can say two solutions to the equation. Your discriminant is going to be, you're absolutely right, it's going to be greater than 0. How is it going to be greater than 0? That it is simply going to be, so for example, it is simply going to be b square minus 4ac is greater than 0. All right, person. And where has this been derived from? This has been derived from, first of all, the general form of the equation. The general form of the equation is telling us what? That it's y is equal to ax squared plus bx plus c. And obviously, you're going to have, it can either be plus or it can be either be minus. According to the color, we've coded it as well. And where do we get this b square minus 4ac is greater than 0? We're going to get it from what you may call your quadratic formula. So if you remember, your quadratic formula used to look at the under root part of it. So my entire quadratic formula was b square plus minus under root b square minus 4ac. So technically, I've just taken out this part and put it greater than 0. Is this clear? Any issues with this at all?
No, Mr.
All right, Pasha. So you just need to remember this. For the longest period of time, Pasha, I did not realize what was the use of this, like this tape thingy. I just use it to highlight stuff which is written. But then I figured out what is it used for. Can you guess? Like this tape thingy. It's actually used to hide, like if there's answers written, this sort of feature of
It's a
good
kind
mark.
of like a character or something, like whiteout.
No. Pasha, it just conceals it. Like, for example, if I've already solved the question, I can just, put this over there. Like, for example, where did it go? Like, I can just do this over the question, and the question will be there, and my solution will be hidden. Clear?
Yeah.
It's like cool. It's cool for me. I can do that. Otherwise I have to copy paste and then erase the solution.
Saves time.
It does actually. All right. Keeping this in mind, what's going to happen now is that this was when you had multiple points of intersection. Similar graph. Let's see. What's going to happen now is that, for
We only
example,
have one point of intersection.
if it has only one point of intersection, well done.
Then the discriminant would be 0, and there would only be one x-intercept.
Then the discriminant is actually going to be equal to 0. Yes, you're right. And you're going to have only one intercept. So now you can clearly see that both of the curves are touching or intersecting the x-axis at just one point in on the x-axis. So what we're going to try and do is that simply, if you have a situation like this, where there is, instead of having one or 2 points of intersection, you have one point of intersection, one real root, and one solution to the equation. Also, there is one thing that you need to notice is that sometimes they will even say the graph or the curve is tangent to the x-axis. What does that mean, Parsa? That the curve is only touching the x-axis at one point. This is also like sometimes this happens that they in the question they might even reference it like this. So these are just multiple ways of telling you the same thing, that the discriminant is going to be equal to 0, which is that the curve is tangent to the x-axis or to the line or whatever it is. All right, whatever the question is. Clear? So it can be this as well. Any issues with this person?
No, sir.
So I want you to know that this type of questioning or reasoning can come as well. Now, at the same time, what's going to happen is that your discriminant is just going to be equal to 0 now. So my discriminant is going to be equal to 0. All right. Is this clear, person?
Yeah.
And lastly, the last sort of iteration of your curve is that it's going to have hopefully it fits. Yes, it does. So the last thing that we're going to have is that obviously there are only three possible outcomes, right? Either it's going to intersect twice, either it's going to intersect once, or
Or it
maybe
doesn't
there's only,
intersect at all.
yeah. The
So
third
your
possibility
discriminant
is
would be less than 0.
yes. Now the discriminant will be less than 0, and you will say that no point of intersection, no real root to the solution, no solution to the equation, and the curve is definitely not tangent. So this time around, we don't even need this. Clear? So these are the three possibilities of your graph having some sort of intersection with the x-axis, or having some sort of intersection with any other line as well. Like for example, it could have any intersection. For example, if my curve is existing like this, Now, what is going to happen? Either a line is going to cut it across completely, or a line might be tangent to it. That can be the case. Or the line does not even touch it at all. Three possible outcomes. So again, you're not going to be looking at the shape or the orientation, or you're not going to be looking at only the what you may call the interaction of the graph with the x-axis. You're going to be looking at the points of intersection. Is this clear?
Yeah.
Any issues with this person?
Uh, no, sir, no issues.
Perfect. Can you write this down for me, Varsa? And now we just need to know that one last thing before you, then you can write it down, is that lastly, where did this discriminant come from? It came from the fact that when you used to find the value of x in your quadratic formula, you simply took it out from there. B square minus 4ac over 2a, and your entire this b square minus 4ac came out from this entire formula. So that is where we got it from. The entire idea of discriminant. Clear? Any issues?
Yeah. No, sir, no
Awesome.
issues.
All right, guys, I'll write this down before we continue. Let me know when you're done.
Okay.
Yes, Parsha, done.
Almost done, Mr.
All right.
Okay, Mr. Done.
All right. So now what we're going to look at is that we're going to see. This is, almost all of quadratics, but one final topic is left, or even not even an entire topic, like a small subdivision of these topics is
Inequalities, basically.
inequalities, as well as what you may call disguised quadratics. Inequalities will not come over here. I'll explain where they come. But over here, what I'm going to be more concerned about is disguised quadratics. And in order to do this, we need an example. For example, what's going to happen is that if there's a question which doesn't look to be a quadratics question, like for example, this is a question that says solve the equation and the equation is given as 4x minus 11x raised to the power 1 over 2 plus 6 is equal to 0. Clear?
Yeah.
This question is a disguised quadratic question. How do we know that? Let's see. First of all, looking closely at this equation itself, I can clearly know that the equation is not your usual quadratic equation. It's not even a quadratic equation. It doesn't look like one. How am I going to go through with this? Is that simply the first and the only step that you're going to use is that you're going to use substitution. All right. So whenever you're going to use the quadratic, whenever you face a question like this, which is not explicitly quadratic, it's the question has a hidden meaning to it, you're going to use substitution. Now, how will you use substitution? Let's see. I have the equation 4x minus 11x raised to the power 1 over 2 plus 6, which is equal to 0. I'm going to use, let's say, let x is equal to, or let x raised to the power 1 over 2 equal to a, for example. Considering this, considering this, now you have to replace it. So it's going to be what? 4. Now, if x raised to the power half is equal to a, then x raised to the power of 1 is going to be equal to a squared, right? Because it's doubling. X times x halved makes x. So if x squared, x raised to the power 1 over 2 is equal to a times a, then it will equal to a square. So that is why technically what this means is that your x squared, oh sorry, your x is going to be equal to a squared. So my equation is now going to look like 4a squared minus 11a plus 6 is equal to 0. Now my entire equation has been completely transformed into a quadratic version of it. It is completely quadratic now. I can solve it easily using my quadratic formula, which is going to be a is equal to minus, um, if we first write down the formula, it's going to be minus b plus minus under root b square minus 4ac over 2a. Then simply solve the rest over here. What is the value of a going to be, Parsa? So it's going to be, kindly calculate it on your calculator and let me know the answer. So it's going to be minus 11 squared minus 4 times 4 times 6 over 2 times 4. Yes, Parsa.
Yeah. Okay. Um.
You're going to have two values of a.
Yeah. So minus. So the first answer is 2.
Hmm.
The second answer is 3 over 4.
All right. Now, one thing that you need to realize is that we've still used this substitution. We have said that a is equal to x and raised to the power 1 over 2. So technically, what have we said is that, whatever value of x raised to a is, that is equivalent to x raised to the power 1 over 2. So x raised to the power 1 over 2 is equal to 2, or it is equal to 3 over 4. Now, in order to calculate the value of x, what are we going to do?
Power 2.
Yeah, we're going to just square it. So it's going to be 2 squared or 3 by 4 whole squared. So lastly, your answer for x is going to be equal to 4,
4 or
9 over 16.
yeah.
That will be your answer. Clear, person?
Yeah.
This is known as a disguised quadratic question. The question wasn't explicitly quadratic, as in, it at first glance, when you look at the question, it it is the furthest away from quadratic. But if you use substitution, you can make it into a quadratic question. Is this clear?
Yeah.
All right. One thing that you need to know is that whenever you have, hmm, whenever, okay, in some questions, you will notice that they will ask for some values of some constants. Like, for example, in this b square minus 4ac discriminant, they will probably hide some value from you, and they'll ask you some sort of, they'll ask you, they'll give you the information required as consider which discriminant to use. Like, for example, they'll tell you whether the graph cuts the equation, oh, the graph cuts the x-axis twice, whether which discriminant you have to use, they'll explain that. But what they'll do is that they'll hide one variable from you and they'll ask you to find it. in that case, whenever they're asking you to find one variable, like for example, if I put in a question, let's try to attempt another question. So this is a past paper question which says that y is equal to x square minus 6x plus k. And they will also, almost always say that k is a constant. And this is the most recurring question in the exam as well. Like it's very well repeated. Obviously, different versions of this questions exist, but the main gist of the question remains the same. So, for example, the question says that this is an equation, and they are saying find the values of k for which the entire curve, the curve that is in the equation, the entire curve lies above the x-axis. Now, they have specifically stated in the question itself that the entire curve is lying above the x-axis. Entire entire curve lies above the x-axis. So, what does that tell us? That tells us that there is no real roots, right?
Yeah.
There is no real roots, or you can say that the discriminant is going to be less than zero. It's going to be like this. Clear?
Yeah.
That we already know. Now they want us to find the value of k. Let's try to find the value of k. So it's going to be
Let's say it's minus 6 squared
hmm,
minus 4 times 1 times k. So it's basically 36 plus 4k less than, no, 36 minus 4k less than 0.
hmm, uh, 4 and a is going to be equal to 1. C is equal to k.
And so we move minus 4k to the other side. So
It
it's
can be
4k
36.
greater than 36.
Hmm.
So k is has to be greater than 9.
Yes, you're right. So for example, it's going to be 36 4k. So k has to be greater than 9. I just switched around the positions of k. Clear?
So there's a way that we know that k is like 9, like from the beginning, if just by looking at the equation itself. Because Mr.
Hmm.
For quadratic equations, we say that it's a squared plus 2ab
Plus b squared.
plus b squared. So 6x divided by 2, you get minus 6x divided by 2, you get 1 and minus 3.
Mm-hmm.
You already know that a is 1.
Hmm.
So minus 3 squared gives you 9.
Yes, that is one way of looking at it, but the reason why we do not look at it from that angle is I'll tell you why. Nonetheless, I'll show you why. We are going to have to again defer to the app that I really like the most, Desmos, and we're going to see. So, for example, Parsa, you're saying that my equation y is equal to
Wait, so Mr. Basically, if k is equal to 9, it would have one real root. If it
Mhm.
was less than 9, it would have two real roots, and if it was greater than 9, it would have no real roots. If it was less than 9, it would have two real roots.
Okay, look at this. If it is equal to 9, it is going to have,
One
look
real
at one real node. Now, Barsa, the reason why you are absolutely right, because they're saying that, your method can actually be perfect to use if they're asking for one real root, because your entire method focuses on it being tangent to the curve, to the line. But for example, your graph can move around. Clear?
Yeah.
Look at this. It can simply move around, and there's only three possibilities. Now you can clearly see 2 points of intersection, 1 point of intersection, and 0 point of intersection.
Yes.
Clear? So and add whenever I increase it greater than 9, you can clearly see that there is no point of intersection on the curve. So that means our answer is correct. Clear? So always remember one thing is that whenever in a question, whenever they say in a question to find, whenever you're trying to find possible values, like let's just say that find the values of k or find the possible values of k, that means that they're going to have exact values in the question. That is what I'm trying to say. And if they're asking for, range of values, like in the question, if it says find the range of values of k, values, then always remember one thing that they're asking for some sort of range. That means that these signs will come into play. All right. Is this clear? Now,
Yeah.
this comes differently, like in other different questions. This is much more applicable, but I just wanted you to know that. And then, for example, the second part of the question is very well tested. That it says find the value of k. Let me find the value of k for which the curve is a tangent to the curve. Oh, sorry. Find the value of k for which the line y is equal to, y plus 2x is equal to 7 is a tangent to the curve. Now, this time around, they've switched things up. Instead of giving you some sort of, instead of giving you instructions to calculate the discriminant using the interaction between the curve and the x-axis. Now they've given you a line as well. And what are they saying? Find the value of k for which the line y plus 2x is equal to 7 is a tangent to the curve. Now, first of all, just by looking at the final information provided to me, this information, regardless of what it is a tangent to the curve. We'll deal with the line, but this is simply telling me that I have one real root, or you can say one solution, one real root, or it just simply means that I can use b square minus 4ac is equal to 0. But there's a slight catch. This time around, you cannot blindly go into using the discriminant with your original equation, because this time around, we're not considering the original equation with the x-axis. We're considering the original equation with what you may call another line. So first of all, you need to find that point of intersection for both the equations. And how you're going to do that is that you're going to equate them two together.
Yeah,
So
you do y equals y.
hmm, so my equation is going to be x square minus 6x plus k and y plus 2x is equal to 7, which can simply be written as y is equal to 7 minus 2x. And now I can put this entire equation into y. All right, I can put this entire equation into y. So what will that give me? It is going to give me 7 minus 2x is equal to x square minus 6x plus k. Now keep this in mind that in the beginning of the question they told us that k is a constant. Now why will we use that, or why will we need that? Let's see. So it's going to be x square minus 6x plus 2x plus k minus 7 is equal to 0. Now it's going to be what? X minus what you may call 4x plus k minus 7. Now, what the reason why I'm pairing up this minus 7 with k is because k is also a constant. So k is always going to take the position of c in this ax squared plus bx plus c situation. Your k and 7 are going to be your constant term. Like, for example, if they had told me beforehand that k is going to be, some sort of coefficient of x or something of that sort, then obviously I would have paired it up over here. But because they have said at the start, they've mentioned it that k is a constant, I'm going to treat it as a constant. Now, this can be written down to b square minus 4ac is equal to 0. Now you've got your new equation to deal with, and you can just simply put this equation in. I'll try to solve it on the other side. So it's going to be, what is it going to be? So it's going to be minus 4 whole squared minus 4 times 1 times c, which is k minus 7. Keeping in mind that k minus 7 is one entire value of c, and that is equal to 0. All right, so this is going to be 16 minus 4.
K would be 11.
Yeah, I think so. So it's going to be 28 is equal to 0. And you take k to the other side. So it's going to be
44
44.
equals 4k. K equals 11.
Well done, boss. So k is finally equal to 11. Any issues with this?
No, sir. No issues.
Clear?
Yeah.
So that sort of like sums up quadratics for you. Now, in our next, today is Saturday, right? We have a class tomorrow. Yes.
Yeah.
So in our next class, I'll try to start something new, because the questions that you will do for quadratics are going to be um,
So when I check the past papers, there's not that many questions related to quadratics.
not at all, Pacha.
They mainly
Like,
question us on like differentiation and integration.
yes, you're absolutely right. And the question that you will have seen, they will mostly around revolve around these. You will find values of k. The homework, I'll not like necessarily homework, but I'll try to give like a few questions, because even I couldn't find a lot of them. Usually the ones that are there that exist are very easy. They ask you to find completing the square. But if we do manage to get questions, they are usually very generic, or they're very one dimensional. He's always asking about values of k. He'll just apply discriminant in a different manner. So the shape of the question is not going to, like, the model of the question is the same, and the shape is just changing. Like, for example, every year, you get a newer model of the car, but the car in its essence remains the same. So that is what they keep on doing. Same model, just slight tweaking. Like, they'll just give you they've given no real roots and one real root. they might give you two real roots. All right, they might alter the question in a disguised quadratic way or something of that sort. So the most amount of change that you'll notice is what we've done so far. It's not going to exceed this. All right.
All right.
In tomorrow's class, inshallah, we'll try to begin our what you may call functions. All right, person.
Okay.
And as always, keep smiling, Pasa. Have a very nice day. And see you tomorrow. Bye bye.